Hello, hello everyone. It's nice to hear you. Nice to meet you. And today we'll talk about deception approach for effective network monitoring. You have already seen the agenda. This is basically what we will be doing today. So let's begin. After this session, we will have a short Q&A part, and I will be glad to answer to all of your questions, of course, if any. Okay, so let's start. We will start with a brief introduction to, to get on the same page with terminology, to understand what we will be testing today, because our session will be mostly practical. Okay, so what is Labyrinth Deception Platform? It is, in general, it is a network monitoring tool which is based on deception technology. So we use decoys to perform this task of network monitoring here. So there we will see how exactly this comes to life, because Labyrinth contains it contains passive part. Also, here's an active parts, and we will see how they interact together so that in result you will get an effective tool. So solution is extremely simple to use. We'll see this as well. And it detects threats without constantly monitoring the network and generating, some kind of vast amounts of data, and without any specialized knowledge in cybersecurity. So even some entry-level specialists will be able to get along with it to understand what is actually going on. Okay, as it was mentioned, Labyrinth uses deception approach here. It's core part of the solution. So in general, just a quick, brief rewind. What is deception overall? So cyber deception, it is a strategy for deploying decoys first to detect malicious activity. So it means when somebody attaches decoys, you get notified about that. And also there is additional goal that may be achieved with deception, which is learn more about attackers' tactics and techniques, so that usually you don't stop the interaction, so you don't block the compromised host, you don't block the attacker overall, but instead you proceed with them to get more information about how they perform their actions and what exactly they are looking for. And this information may be used for your further improvement of your of your real infrastructure. So in general, if you are talking about cyber deception, anything can be a decoy. In deception overall, even a sandwich that you leave on the counter, it can be a decoy. But in terms of cyber deception and in terms of our today's topic, we will be mostly referring to network decoys and also file decoys here. Okay, so before we proceed with the live cases with some examples, I suggest that we talk about platform, how it works, and as I mentioned earlier, some terms that will be useful for us today. The first one, first thing first, components. It means what the platform consists of. In general, solution works on two types of virtual machines. It's admin VM and worker VM, which means that that's all that you need to run it. As well, we will be talking today about Zero agents and the real hosts on which they should be deployed, and also, of course, its points, its decoys, because they perform the main job when we talk about deception. Because as we mentioned earlier, deception is all about placing decoys. Decoys, honeypots, so many different names here. So talking more about infrastructure, as it was mentioned earlier, we have two types of VMs. It's admin VM and it's also worker VM. So admin VM or management console, it is the main module that provides you with a web interface. It collects and stores information about security incidents. It generates alerts, etc. And it also includes multi-tenancy or environmental isolation, in other words. So what does it mean? That admin VM is, or management console, as you may guess from its name, is all about managing. It's all about configuring your platform, configuring what actually it will be doing and the way it will be doing. On the other hand, we have worker VMs. So worker VM, it is also a VM, but it's designed to create, store, and launch network decoys. We call them points. So in general, there can be only one admin VM because here we have centralized management. But there can be as many of worker VMs as possible. There is no licensing based on that. And this way, Labyrinth can act as an MSSP when the owner manages the admin VM and you place worker VMs in the client infrastructure. Okay, so everything should be clear here. Next, we have Honeynet. So what is a Honeynet? If put official, it is a network segment with specific parameters in which decoys operate. But if put in simple terms, Honeynet is a configuration where you define where you would like to place your decoys and which exactly decoys you would like to run. After creating this configuration, you can run it, and as you can see from my slide, they are deployed. When you see this green shield in front of status. Next, we will talk about points and pointer bases. So points, those are decoys, those are network decoys. This is the name that is used in Labyrinth. And what is special about decoys? In general, point it is a network bait for the attacker, which simulates a variety of IT services. So starting from, I call it basic IT. So those are services that can be commonly found in IT networks, like SSH servers, like web, and etc. And up to OT, also including IoT here. So decoys, so points in Labyrinth, they have this layer of vulnerabilities. They are actually vulnerable because we want to add this part of engagement when we make the attacker interested in what in this asset. So the more they play with this toy, so we provide them with a toy, the more they play with that, the more information we get from them. So this is, this is some kind of trading here where we get more because this is our field. So here it is. What is also special about decoys is that they can be customized. I'm saying can because this approach is completely optional. And remember, I told that solution is really easy to use. It's really this way because solution was created by a team of engineers who work in the field for a lot of years, and they tried plenty of tools. And sometimes it happens that you have effective but really complex tools that requires you months of training to understand what is basically going on. From here, it's not. So we provide you with a bunch of predefined point types, so predefined decoy types that you can use. Or if you would like to get further into that, you can do customization. You can create custom point types using YAML configs. And today we'll see in general how it looks, some of the examples. Okay, let's see. Next, we have CIDR agents. This part of infrastructure is optional, but anyway, it provides you some benefits. If it didn't, I wouldn't even mention it here today. So CIDR agent is a binary. The main idea here is that you put this binary on your real host, you run it, and you receive decoys, file decoys, breadcrumbs that will lead your attacker to a deceptive infrastructure from your real assets. On the screen, you can see some of the types. So types define which platform we currently support, so on which platform you can run it. And today we will see them in action. We'll see how they actually help, because you get in general two benefits. First, it's as it was mentioned, logical links between your real and deceptive infrastructure, and second, it's additional vectors or additional ways of integration, where we can not only detect some activity that happens to the decoys, but also we can detect activity that has nothing to do with decoys. We can detect if those files are being used. So stay tuned, we'll see that today as well. Okay, so really important, almost the most important part of any deception solution here is that to get notified. It's about alerts here. So alerts, those are notifications about anything that happens to decoys, and therefore, you see, if something happens to decoys, even if it's not for misconfiguration, we have such cases. It means that something goes wrong. It means that something is not the way it is intended to be. And for this matter, even if it's not real attacker, but as I mentioned, network misconfiguration, you can use it and get further to understand what is going on. And here's alerts. Today we will generate some. You will see of which parts they consist of, because example that you see on the screen is enclosed state. What we also see from here is that platform has an internal incident management functionality, which is implemented in the form of various states, which you can see on the screen. And you can switch between those states to keep synchronized with your team. And we will also get to it later. Okay, so this was first, I would say, the most boring part here, this theory. And next we will proceed with more practical, more precise cases. We'll see how the platform works. So what we see from here, first case that we will be covering today is web-based deception using OWASP Top 10. So let's proceed. In general, our journey with web deception is long, and we had some major steps to get where we are currently here. So at first, when solution was created, we noticed that there is a major gap in web deception, to be more precise, because web currently is almost, you can say that it's one of the most popular segments that is being attacked, is being used constantly, and we need some kind of tooling to, to cover this gap. So it first started from manually crafted web pages. We still have them. It's, for example, FortiGate Web UI, VMware ESX Web UI as well, and many more. And the idea behind that is that those are lightweight web services that you can quickly start, you can quickly rearrange them. But they were lacking this, part of engagement that we mentioned earlier. It wasn't that interactive. So even though, it contains some vulnerabilities, it wasn't as interactive as we wanted. Next, we made some steps into making this approach, more make it easier. So we wanted to scrape web interfaces, and we still had this as HAR archives, which you can generate from your web browser, but it still was lacking this part. If it was more interactive, but we wanted to get even more from here. And this is why we went to creation of the special point type that is called universal point. So this decoy provides the most realistic output. You can say that it clones your real web application, but adds some parts of vulnerable services. And as a result, you get this easy to use, easy to create. So this tool, you got this decoy. So this is how it looks. Universal point in general, it is the only type of decoy that requires, if even minimum, but still configuration, because we need to know what exactly we will be emulating. So for this, you need to specify your upstream URL, which is a URL of what we will be emulating. So on the example that you see here, we are emulating our website. So key points about universal point. First, it can emulate anything that has a web interface. So it's not just websites, it can be your network tooling and, for example, switches and routers that have web interface, if you, of course, allow that. It can be also web interface of some OT devices, like anything, as I mentioned, anything that has a web interface here, it can be emulated. Next, it's highly interactive, so we'll also see that today. And it's flexible in configuration, in its YAML configuration, because today we will also see how many parts you can actually emulate, how many from this, at the first glance, simple configuration you can actually get. And today we'll try one simple case. It will be simple LFI. Happens, you really need to omit this kind of vulnerabilities, and we'll see how it looks. So as for now, I would like to switch to my desktop, if that's right, and we will test it. One second. Okay, so let's begin. So from here, we can see my browser, and we will be using some terminal. I think I will make this top bigger. But if needed more, that's fine. You can ask it in the comment section. So let's begin. First of all, from here, what we can see is our dashboard. Those are tenants that you can switch between. So yeah, this is our dashboard. It's fully interactive, so you can click on different parts. You will get forwarded to parts that I mentioned here, to part of the interface. From here, we have HoneyNets. So those are my network configurations. So this is what I was mentioning, that you have this config where it specifies where you would like to have the decoys and which exactly. So that's it. All you need to do is to click and define how many of those you would like to have. Your only limit here is, license. Okay, so let's see. We will go and check if I have any of the universal points. We have, here they are. First I will copy this value right here. Self-signed certificates, we know them. Click on details, and in details we can see more information about this exact decoy, which configuration it uses. You see some additional information. So let's see. We scroll down, and we want here to get this upstream URL. And as you can see, it's still our website, the same that we have for our example here. So let's see. So this one is fake. This one is real. Maybe you want to know more about about the solution. For this, you can go to the knowledge base. It contains some documentation that you can use, some further solution description, and we also have some case studies. So this one is fake. Let's scroll down, and this one is real. So you can see from here. But if you remember what I told you, you know the difference between those two is that universal point is actually vulnerable. And continuing with our goal to perform LFI, we'll do that. So something extremely simple. Let's get, for example, I will make a guess that there is present HTTP password. I will just try. What can go wrong here? Okay, I will copy that for our future. And we have it. Okay, really bad news for our development team if we have the same on our website. And you can see that nothing happened. So this file, it was fully made up by Labyrinth. It's not something that is taken from your original application. And this data, for example, can be used for further reference. It can be used for example, gathering all of those usernames and putting them into word list. If using the same approach with LFI, you can also get to ADC shadow or etc. You can get hashes and play a little bit with cryptography and form word lists of that out of that as well. So there are plenty of ways where the attacker can go. And this is only one of the examples, one of the attacks that we actually saw here. But of course, our goal here, we talked about that, goal of deception, you want to be notified. And for that, we go to alerts. So what we can see, there are two similar alerts. Here is file access attempt and attempt to exploit local file inclusion. Let's explore. We will also talk about alerts. So you see all of the alerts can be expanded. And from here, you also receive network dump and also mapping to MITRE. So let's scroll down. In this alert, you can see that service name is web application firewall. So that's true. Each universal point contains web application firewall, which works on OWASP CRS, and it covers, of course, OWASP top 10. And it allows us to get this more precise detection. The second alert is if we scroll down, by the way, so here's mapping to MITRE. So even if you decide to analyze alerts, not in Labyrinth, but for example, in any other solution, or for example, you put everything in SIEM and do notification, do any actions from there, or you have source solution. So you always know what is going on because we have mapping to MITRE. You always understand what does this alert reason mean. Okay, let's scroll down. From here, we can see that service name is web. The rest of the tabs, we will talk about them later. And let's proceed. So it's not all about universal web point, because the same universal web point that you saw, oh, my bad, you may notice that it contains some part of configuration. I can say that it's my favorite part. It's called root, and it allows us to get create fake paths that are not present in the original web application. In my case, it welcomed a demo. Let's see how it looks. Let's also check networking. Maybe we will find something in there. And you can see some interesting headers. So make sure to omit having them in your production environment. If we do absolutely the same for our original application, nothing happens. So from here, you can see that I specified what I want to show. I specify which headers I would like to add, which methods are allowed to use, and which status code will be returned. Using this approach, you can basically emulate, for example, fake API endpoints, customer messages, and etc. So this is what I was mentioning. It's really easy to configure, but you get this much of interaction in response. And if you go to others, you will see that we have been notified about access to fake root. Okay, so let's proceed. I would like to switch back to my presentation. So let's go to our next case, and it's Seeker. So this is what I was mentioning, that that Labyrinth actually contains of two parts. First one is passive, which is decoys, because decoys are waiting to be touched, are waiting to be attacked. And Seeker, it is an active tool that allows us to actually get this notification. So let's see. Seeker architecture is extremely simple from here. It uses already what you have in your Labyrinth appliance, so you don't need to install any additional tools or whatsoever. Everything is already present in your appliance. So everything is already in the platform. It's extremely easy to configure. All you need to do is to provide chain of events that will happen, so chain of actions that will be done, and configure if you would like to have it regularly, like scheduling, and that's it. Next, it's the scheduling part allows for regular assessment, because Seeker is one of the goals of the Seeker is to provide these constant checks. And why not to use it if it's included in the subscription, so we don't do any licensing. For Seeker, you can use it freely. So what it can help? First is security controls validation. What does it mean? You have already running tooling in your system. Is, for example, SIEM, NDR, or anything else, and you want to, or for example, IPS IDS, and you want to know if it works the way it's intended. Seeker can help here. Next is security policies validation. So if you have a policy that, for example, SMB signing should be enabled everywhere, and you want to easily check all of your hosts that you have, you can also use it. One of the examples, but the idea is that you can check if rules that you want to maintain in your infrastructure are actually working. You can use Seeker. And we also have a case when our clients tested their SOC team efficiency, and for that you can also use Seeker to test how your team will react to this reset action. From my personal experience from using Seeker, I can also add that it covers some parts of compliance, and then I will see the example. So let's proceed. So the workflow of using Seeker: first you upload payloads. It's optional. If, for example, you want to use any word list, or I also use sometimes binaries, so you put binaries and check if there will be any kind of shell. If I will be able to get a shell, it also can be used here. Next, you create scenario. So you see, scenario defines what actually will happen, and it works in a chain. So what does it mean? It means that results of one action will go to another one, and this way you have this chain of action. An example you can see in your screens. And next, you create and run simulation. Simulation is about defining some parameters, like starting point, so where our chain or reaction will start, and also about defining scheduling, so how often you would like your scenario to be run. Okay, let's define our task. Our task here, I am an engineer, and my company wants to have PCI DSS certified for that. And if I go to if I check guide, or for example, here I used quick reference guide because they have this really pretty table. And it asked me, do not use vendor supplied defaults for system passwords and other security parameters. So my goal for today is to make sure that nobody is using default credentials. How can I do it? Of course, you can do it. I can do it manually, but I don't want to do that because I have plenty of hosts in my network. It will take ages. I can try and do some kind of scripts, or I can make it the easiest possible way is to use Seeker, because I have already Labyrinth installed in my network. So it can be either, even we have this for POC. So I have this tool and I would like to use it to get my job done. Okay, I will be switching back to my screen. So what we will be doing here, I need to go to Seeker and I need to create scenario. You see that I have kind of similar scenario, but we will create it from scratch. I want to perform default credentials periodical checks, and I will start from SSH host. From SSH, SSH is present of plenty of tooling, popular thing. And for this, I need to first create a scenario. So let's do it. I click on this plus sign, and let's begin. I have this name already. Okay, let's have it this way. Let's make it more pretty. I will use the same name. Description is optional. Okay, and next we have to provide those actions. Exactly, we need to create this chain. First, I will, of course, I can start from, I can check broad network, but to make it faster for us today, I will be checking only one host. So for that, I will start with ping. Okay, I can specify target, or I can emit it. Anyway, it will be specified in simulation. Let's have it, and I need to specify request count, so how many of requests will be done. Easy. Next, because I'm dealing with SSH, I want to know if this port is even open. So you see, I'm not specifying target because it will be taken from my previous action. Port, 22nd, okay. Next, brute force SSH. Okay, this one. And exactly, I will be using that to check if any of the default credentials are being used. I have prepared, default usernames and password word lists in advance to make this process easier, and I will be simply using that. Click submit, and that's it. Target, once again, it will be overridden by previous action, so I'm not specifying it. Click submit. Last but not least, as a bonus step, I want to know what exactly my attacker will be able to get if they get to execute command. So it will be simple ID, username and password will be taken from previous action as well as target, and that's it. So I click submit, and we can use the scenario. To run it, we need to get to simulation. So we click on plus sign. Today's Monday. Next, I choose Seeker agent. It's already part of the system. So it's Cedar proxies that you saw in HoneyNet. Next, we choose scenario, which means what exactly will be done. This is our scenario that we created. And I can specify the same target, or I can override it. Click submit. And next, I want to schedule it. I can schedule it to run daily, weekly, monthly, or even once a year. So you see, I can specify that only on Tuesdays and Thursdays, my scenario will be running, and click submit. And that's it. You can run it manually by clicking on Start, and that will be it. To make it, I can start it actually, and you will see how it looks in action. You see that status was changed in progress. If we go to details, 1 second, you will see that is in progress. Currently, we are on pink stage. So you can either wait for this next run or for this next run, or you can manually run it anytime that you wish. Let's see. So ping is done. You can click on show results. So ping was successful. Port scan as well. You see we found this port. And currently we are doing brute force. You know that brute force is kinda time-consuming task, so we need to wait. To make it faster, I will show you the results of how I checked my workstation. I click on details the same way that we saw earlier. So the ping port scan was successful, but brute force was not, which means that you see we didn't find any pairs of usernames and passwords, and it means that my host is all right. It works as it should be. Other example that you can see from here, I check state of web application and try to perform some attacks. There are also some examples of I did also this stuff with SMB check, and you can, in general, you can do plenty of combination using those actions. So you can see them all from here. They're being constantly updated. I mean the quantity, and it can be used exactly from what it was intended to, is to get you an active and easy to use tool to check your security policies, check your security tooling, check your team, and also be prepared for some parts of compliance. Okay, so let's proceed. For this, I would like to switch back to my presentation. 1 second. And we will continue. Our next case will be about guiding the adversary. So we will talk about using breadcrumbs here. The workflow of using breadcrumbs is extremely easy. First, you need to generate this binary, of course. You can generate it by clicking on this build button, as easy as it is. Next, you should put it on your real host. For example, I used SCP, but you can use, because I have only one host, and it's for demonstrational purposes. But you can use plenty of different tools like Ansible or anything that you prefer in your environment. And next you need to run and specify to which the proxy you will need to connect. So remember we have CIDR proxy and it does two things. First, it's proxy for between CIDR agent and admin VM. And plus it contains Seeker agent, which is used for Seeker scenarios, for Seeker simulations. As a result of this workflow, you will get CIDR tasks. So those are breadcrumbs. As I mentioned, we call them CIDR tasks, and they contain plenty of information about decoys. So we are not putting some kind of nonsense there, just for it to be present. It was created to actually guide the attacker to your deceptive infrastructure. And now we will try and test it, to test how it looks. So I'm switching back to my appliance. 1 second. And let's see. First, in CIDR agents, you can see that I have my real host on which CIDR agent is present. This is Windows, this Linux, you can read it from here. In download, you can see those binaries that we mentioned earlier. Next, we have tasks. So tasks are exactly those breadcrumbs. So I must say that a quantity of those tasks and their type, it heavily depends on what you actually have in your environment. So from this table, you can see that we have, you can see where they are located, you can see to which decoys they are actually binded, and which type. So you can either click on details and see what's inside, or you can go to this host and check. So this is exactly what we will be doing. Yeah, my host. Let's see. And you can see you can do absolutely the same from your host. So we will try and use this data. Our first case will be, I would say, pretty straightforward. We'll try and use what we already see. So let's run. We need a password. So we have it from here. And as is being told in Hacker Movies, we are in. And from here, we can do some pretty basic stuff, just to do basic tests. I like to check processes lists, maybe continuing with ATC password. Remember, we got it from our universal point, so it's here. Maybe we are lucky and we have access to the internet. Oh, we have, and from here we can proceed and do some testing. So yeah, this was our first case. I must say that we will continue with this on our next example. But as for now, we want to get to know if we have any alerts. By the way, you can also have the preview of we have in those latest alerts tab. We go here and we see there was connection to SSD port. There was successful login. There was an attempt to get processes leaked, and there was an attempt to get ATC password contents. Exactly what we did. Let's explore more precisely. As I mentioned, we have a pickup, network dump. We have train mapping, and in events, we can see what exactly led to this alert to happen. So as you noticed, now we don't bomb you with all of the data that decoys receive. We collect this data from decoys, from points, and we analyze it, and you receive alerts in an easy to understand form. But if you want to learn more, you can always get them from Events tab. So from here, what we can see, you can see that I was connecting. You can see fingerprint, okay. You can see which credentials I was using and exactly what I was running, each and every of my comments, everything is provided in here. In addition, we have a tab for changing the state. It logs change of the state of the alert itself. Exactly what we talked about incident management. So there are 4 states. In progress use if you are currently working on this case. Ignored means that you don't want, there's no need to continue investigation, and closed means that you finished working. Good, finished working on this case. Click submit, and you see that user changed alert status with a message. Okay, so this was pretty easy. From the perspective of different decoy types, you can see that we have some shortcuts and etc. As I mentioned earlier, it heavily depends on what you have actually running. But we can make this case more interesting. For this, I will be switching back to my presentation. 1 second. And we have it. Last case for today is two-way integration with SIEM. This is exactly second advantage of using CIDA agents. So how it works? Those two-way integrations, they're currently present for IBM Curator and Splunk. We are also working on expanding this list, and we are open to discussion with our partners, with our clients, and etc. So it's free of charge. Anyway, you can send logs to any SIEM of your choice, even without this two integration. Currently, is presented only for Splunk and Curator. So what does it mean? Why it's called two-way? Because we are not only sending logs to SIEM, so logs from Labyrinth to SIEM, but we are also retrieving logs to generate alerts. So we detect if somebody used fake credentials that are intended only for deception, to use it on your real host. Because, it's quite common that we have in our infrastructure the same naming policy. Sometimes people even tend to use the same passwords for different hosts in the network. And it's not bad that we have the same naming policy. We just need to be aware of that, and we just need to know that it can be used, and we can work around this fact as well. We can turn it into our advantage. So yeah, that's exactly why it's called two-way, because we send and we also retrieve. Let's see example usage. So that's exactly what I meant, that attacker can try to connect to real host using the subject credentials. So if this host sends its logs to SIEM, and you have integration with the SIEM enabled, you will get notified about this activity. So now I will be switching back to my appliance and we will test it. So first thing first, settings, integrations, to make sure that our configuration is applied, is that our integration is enabled. So Splunk, Curator. For Splunk, you can see all you need to do is to provide API host, port, and also query. The query will define what exactly you will be searching for. You can also do enrichment if you can. In my case, Splunk here is mostly for demonstrational purposes. So it's just the same query. I don't have anywhere to get enrichment from. And for Curator, it's easier. You just specify API host and API token. And that's it. So we have our configuration, and we can proceed with our case. So from here, we have those credentials. I will use the same one that we use for the subject host, but I will try to connect to my VM. Windy password. I take this one. Will it work? It won't. Okay, maybe something else. No. Maybe this one. No as well. So I'm the owner of this VM. I have created it, I have set it up, and I know that this VM doesn't have this user. This user is completely fake, and it was created for deception, for information for its username, passwords. It was taken from word list that I specified in my Labyrinth. So there's no chance that this user is present. This is why it's important to differentiate your naming for decoys and naming for your real assets. But what happened is that this host sent its data to SIEM, and we can actually check it. I have my Splunk. Okay, and you can see there was failed password for invalid user, exactly the one that we used. So what will happen is that we will get notified that it happened. You see that here's fake credential usage detected. you can scroll down and see which username was in use and where my attacker tried to connect. In general, this additional info for Splunk, it can be expanded. You can add whatever you actually have in your SIEM. In my case, it's just username and IP address. For IBM Curator, it works absolutely the same, and I will show you how it looks. In my case, you see it's by username. If you scroll down, you can see which username was in use, and you can check log source name. And yeah, so this is how it works in general. So even though this part is optional and two-way integration works in conjunction with CIDR agents, CIDR proxy, and CIDR tasks, you can see that you get broader coverage even if the attacker doesn't explicitly use decoys. So yeah, so this is in general how the solution works. Please, I would like to switch back to my presentation slides. One second. So, 1 second. Sorry for that. Yeah. So we tried a couple of cases, a couple of examples, even if they are simpler than what can actually happen. It's just a glimpse of how solution works. So I encourage you to contact our dear friends, Looptech, and we can arrange a POC. You can test it for yourself, and I'm not a salesperson. I'm an engineer. And I really encourage people when they are even trying the solution is to perform as many of different cases, whatever they can come up with. If you're a team or even if you're just an enthusiast, it will be an interesting experience. And I really enjoy, gathering those stories. So yeah, thank you so much for you today. Please contact Looptech for more details. And we will be looking forward to hearing from you to get to help you to improve your cybersecurity posture. As for now, we have time for a Q&A session, and if you have anything, feel free to drop it in a chat, and I will do my best to respond. So thank you. Okay, so I see that please, dear admins, let me. Okay, so no questions. So thank you so much for your time today and hope to see you. Bye.